What if your computer could become 1,000 times faster without getting hot? Imagine downloading an entire movie in less than the blink of an eye. Imagine AI systems responding almost instantly. Imagine data centers consuming a fraction of the electricity they use today. It sounds impossible, because for decades, computer engineers have faced a frustrating problem. The faster computers get, the hotter they become. And eventually, that heat becomes a wall that technology can't easily break through. But now, scientists in Japan may have just found a way around it. A breakthrough so powerful that it could completely change the future of computing. And if it works outside the lab, it could transform everything from artificial intelligence to the internet itself. The big problem nobody talks about. When most people think about faster computers, they think about speed. But engineers think about heat. Because every calculation a processor performs generates heat. The more calculations, the more heat. That's why gaming PCs need giant cooling systems. It's why laptops get hot. And it's why some of the world's largest data centers look more like power plants than computer rooms. Thousands of servers, millions of calculations every second, and an enormous amount of energy wasted as heat. In fact, heat has become one of the biggest obstacles preventing computers from becoming dramatically faster. The secret inside every computer. Everything your computer does, watching videos, sending emails, playing games, using AI, all comes down to something incredibly simple. Bits. Tiny pieces of information represented as either 1 or 0. Every photo you've ever taken, every YouTube video, every AI-generated image, all of it is built from billions and billions of these tiny bits. The faster a computer can process those bits, the faster everything becomes. But here's where things get crazy. A speed that almost sounds impossible. Today's advanced computer chips process information incredibly fast, usually in billionths of a second, known as nanoseconds. That already sounds ridiculously fast. But the new device developed in Japan is operating on an entirely different level. Scientists say it can process information in just 40 picoseconds. That's 40 trillionths of a second. To put that into perspective, a picosecond is to 1 second what 1 second is to roughly 31,000 years. That's how tiny the timescale is. And according to researchers, this breakthrough could eventually make processing speeds up to 1,000 times faster than existing technologies. The amazing trick they used. So how did they do it? Instead of relying entirely on electricity, they used light. Yes, actual light. Researchers built an experimental device using ultra-thin layers of advanced materials. Then they fired incredibly short pulses of light into it. Each pulse lasted only about 60 picoseconds. When the light struck the material, something fascinating happened. The tiny magnetic properties inside the device changed almost instantly. Those changes represented digital information, meaning data could be stored and switched at extraordinary speeds without generating the massive heat normally associated with high-speed computing. It's almost like replacing a hot gasoline engine with something cleaner, faster, and more efficient. Why this could change AI forever? Now, imagine what happens if this technology succeeds. AI is exploding. Every AI model requires enormous computing power and enormous amounts of electricity. Some AI data centers already consume as much power as small towns. As AI continues growing, energy demands are expected to skyrocket. But what if processors suddenly became dramatically more efficient? Imagine faster AI, faster cloud computing, faster internet services, lower electricity usage, less cooling infrastructure. The impact could be enormous. Not just for technology companies, but for everyone using technology. Which means, basically everyone. The billion switch test. Here's another reason scientists are excited. The device wasn't just fast, it was reliable. Researchers tested it through more than 1 billion switching cycles, over and over. Again and again. And it kept working. That's important because laboratory breakthroughs often fail when pushed too hard. But this device remained stable throughout testing, a crucial step towards real-world applications. There's still a big problem. Before we get too excited, there is a catch. Actually, a few catches. The device relies on tantalum, a rare metal already in high demand. Building billions of these components could create supply challenges. Then there's manufacturing. Creating one device in a laboratory is one thing. Producing millions or billions of them for commercial products is something different entirely. And finally, scientists still need to prove the technology works outside carefully controlled laboratory conditions. Nature has a habit of introducing problems that laboratories don't. The year 2030. Despite the challenges, researchers are optimistic. They believe a prototype chip could be ready around 2030. That's only a few years away. And they think future versions could become even more efficient by making certain layers even thinner. If successful, this technology could become one of the biggest computing breakthroughs in decades, maybe even one of the most important.